Okay, guys, so we are here to review exponents and roots, one common topic in these exams. So let's go over the very basic concepts. Mainly, we're gonna go over the properties. What are the properties, the different uh, things that we can do to play with these expressions whenever we're dealing with an exercise in this category in the exam. So let's talk about exponents. So remember, whenever we talk about exponents, we're referring to the following sort of expressions. That it can be, I don't know, 2 or I don't know, any other number, 4 to the power of 5. Okay, what this means is that I will end up multiplying 4 5 times. So 4 times 4 times 4 times 4 times 4 and times 4, right? This is how we express it. But there are certain properties that we can use, we can play with to solve exercises. So the first set of properties that we are going to discuss are when the expressions have the same base, okay? So whenever we have expressions with the same base. Remember that the base is this number right here. This is what I will call the exponent, so when the same base. So if we have expression with the same base, let's say that the base is x, so x to the power, I don't know, could be 2. If I multiply them, so times x to the power of 4, in this case, the property says that if I multiply exponentials and they both have the same base, this is the same as leaving the same base and simply adding the exponents, okay, to the power of 2 plus 4. So in this specific case, x to the power of 2 times x to the power of 4 will be equal to x to the power of 6, okay? I leave the same base and I just add the exponents. That is the first big property, okay? Now, the next one. What happens if I'm dividing? So let's do the same case, the same exercise. So let's say that is x to the power of 2 divided x to the power of 3 in this case. If I have this scenario, I leave the same base, and what happens is that now I will subtract the exponents. So 2 minus 3. So that means that x to the power of 2 divided x to the power of 3 will be equal to x to the power of negative 1. Okay? I just subtract the exponents. Clear? Now, normally we tend, or there will be certain exercises where dealing with negative exponents is not that friendly, or we don't feel that comfortable with. So there is another property that we can do, or we can use to work it out better. So let's mark it here with a little asterisk. This is the first property. This will be the second one. Let's go here with the third one. And it says that when you have a base to the power of a negative exponent, let's say to the power of negative 5, this is equal to, pay attention here, I find the inverse, so it will be 1 over x, and here you just leave the same exponent, but it becomes positive, okay? So that will be a nice trick if at any given moment you do not want to deal with negative exponents. You do this, the inverse, and you get the exponent to be positive, all right? Let's see what other one we have. This one. Okay, there is another one, of course, that we get to use frequently in these exams. If we have the exponent, right, let's say x to the power of 2, and all this expression is to the power of another exponent, so x to the power of x squared, all this thing to the power of 4. So in this case, what you do is you leave the same base and you multiply the exponents, okay? So in this case, x squared, everything to the power of 4 will be equal to x to the power of 8, okay? That will be the fourth property that, again, is commonly used in these exams, okay? Now, let's continue. We do have another property that is one that is less known, so that's why it's fairly common for these people to evaluate it within the test. And what happens if I have the number to the power and the power is a fraction, okay? So x to the power, I don't know, let's say that is 3/4. So the property that we get to use is that whenever you have an exponential that is a fraction, we can transform that into a radical, okay? So this will be equal to the root. Now pay attention here. The denominator, in this case 4, is gonna become the value of the radical, okay? So this will be the fourth root, and then the 3 just sticks to the x. So here inside I'm gonna have x cubed to the power of 3. All right, let's get here with another example. Let's change the variable. If I have a to the power of 2/5, okay? If I want to change it, this will be equal to, again, this guy, the denominator becomes the root, so it's the fifth root of a to the power of 2. That's how you transform it. Very useful, well, for the test. It's not something that it will be actually very useful in life or in mathematics, but this is one of the properties that very commonly these people tend to evaluate, okay? So these are little things that we know if we are given the same base, right? Now, what happens? Because it can be the case where we don't have the same base, but we have different base. But the characteristic is that we can have a different base, but with the same exponent, okay? That's gonna be the feature. If we have this scenario, we can play. There are a couple of things that we get to do. So, for example, if I have a to the power of 2 times b is a different base, but again, also to the power of 2. We have different bases and the same exponent. This is the same thing as saying this is a times b, everything to the power of 2. So yeah, I just multiply the bases and I leave the same exponent. Similarly, we can do the same when we are dividing. Say that you have x to the power of 3 over y to the power of 3. This will be the same as saying this is the result of x divided by y, everything to the power of 3. Okay? These are properties that we get to play with. It can go either way. You have this expression, and from here you go, you split it into a squared b squared, or you have this expression and you go and split it to the other side, okay? The other way. Either way is going to be quite useful for us to know. Lastly, there are a couple of things that I just want you to remember, okay, that are going to be important whenever we talk about exponents. So for you to remember, first big aspect, remember, 0 to the power of any number is equal to 0, okay? Don't get confused. Now, any number, right, to the power of 0 is equal to 1. Keep that in mind. So here as an example, if I have 3 to the power of 0, this is equal to 1. If you have 127 to the power of 0, this is equal to 1. If you have negative 7, all these things to the power of 0, this is equal to 1, okay? That is the condition. So pay attention to that. Now, let's talk, as we just did in properties of exponents, let's talk about some properties on the square roots, okay? Whenever we have the square roots, okay, there are a couple of things that might become handy at some point in the test. Say, if you have the square root of a multiplication, in this case, the square root of a times b, this is exactly the same as expressed in this form, the square root of a times the square root of b. And then again, you can play back and forth with this thing, with this property, depending on the exercise that you're facing. This property also applies to with the division. If you have the square root of a division, a divided by b, this is the same thing as saying the square root of a divided the square root of b. Okay? That's another property that we get to use. In this case, properties of roots. For you to know almost by heart, okay? Or let's say that is one of the properties that we discussed a few minutes ago in the exponents, but let's analyze it backwards from the standpoint of the square root. If you have the square root of an exponent, saying, let's say, x to the power of 3. Again, if you don't see anything here, remember automatically that this is supposed to be a 2. This will be equal to x, and we create a fraction where the numerator is the same exponent that you have inside the root, so it's going to be 3, and then denominator is the value of the root, so in this case 3/2. Okay, where the numerator is 6 and is still being 3, and the denominator is just the value of the root that you have. So again, you can go back and forth with this thing as you may need in any given exercise. Okay, clear? One last property that maybe in exams like the SATs or the ACT you don't see it that often, but I have seen it a few times in the GRE or GMAT, is the following property. If you have, let's do it both ways. Let's read this sentence. If you have the square root, remember that this is kind of a 2, of the square root of y. You can just kind of add the root, so 2 and 2, so that will be 4. This is the same thing as saying this is the 4 root of y. Let's do that again to be super clear. And it's not only with the square roots. I mean, I can have the square root of the third root of c. This will be equal to the sixth root of c. Right? You're multiplying the values of the radicals, okay? That is a property, again, that it will be handy. Not that common to see kind of exercises dealing with this property in the ACT or SATs, but GRE, GMAT, every now and then you might be facing an exercise where this concept will be important. So I hope that this is clear. Again, it's a quick review or basic concept of mathematics that will be useful for you to face this exam.